There we go. All right. Yeah, we were also making changes to the deck as we stepped up here, but we really want to talk today about data sanitization, how it contributes to a circular economy. And I'm here with Jonmichael Hans, VP of Chia Network. My name is Arie van der Hoeven. I'm a principal product manager with Seagate Technology. I'm one of many people at Seagate who works in sustainability, not actually on the team, but I'm on the planning side. So let's start by looking at where data is going. And this chart looks a lot like some of the charts you saw in the keynotes where we're talking about increases in energy consumption in data centers, for example. And the data growth is just amazing. You know, if you look at it from 2019 to 2026, just an amazing growth in CAGR. The good news here is that new technologies are allowing us to increase our aerial capacity so that even though data is just growing at a really incredible rate, so are aerial capacities. So we hope that as we move from 20 terabyte drives to 30 terabyte drives to 40 terabyte drives, that we can keep up with this pace and that those drives have a very similar carbon footprint to the prior generations. So we hope that a 40 terabyte drive is somewhat similar to a 20 terabyte drive. We're doing that through things like at Seagate next year, we're releasing drives that have heat-assisted magnetic recording. We're actually using lasers now to really try and get the tracks per inch, the bits per inch, even narrower and narrower. So we have lots of new technologies on the horizon. We expect our pace to continue. Unfortunately, all this incredible amount of storage, and storage is a large part of the mass in a data center. It's probably a majority of the TCO in a data center. So it's kind of like the big elephant in the room that people ignore. It's just really incredible, and these drives are just destroyed, and they're destroyed early. You know, if a rental car company were to, say Hertz were to, destroy their cars after 30,000 miles instead of reselling them, that's the analogy I'm going to use. So, all this data is being driven by AI, and really data is the oil, for the fuel for AI. And AI is being used for a lot of things that also help with sustainability. More productive factories, autonomous vehicles, a lot of promise there, smart cities, and advances in human genomics, for example. So there's just incredible potential with this data. But at the same time, we've got to be more mindful about how we use it. And circularity is key. We're one of the early companies in our industry to do life cycle assessments and publish them every year here at Seagate. And we look at this in 4 phases. Design, of course, increasing the capacity, making it easier to recycle, looking at things like how can we reuse the magnet assemblies. The most critical component in a drive is the rare earth magnets, the neodymium. And if we can recycle that, that's a huge benefit. And Jonmichael will go more into this later. And I already forgot to plug the paper, which I was supposed to plug. We have published a paper called Data Sanitization for a Circular Economy. Jonmichael led it. I was one of the authors. And once I finish my part, John's going to go into more details about the paper. And then after we finish, we're actually going to post a link in the presentation because we forgot to. Looking at manufacturing, making sure that we're using less water, renewable energy in our factories, trying to increase recycled content. We need to do a lot better there. We have very little today. Looking at the life of the drive, always focusing on power consumption. And we have technology now, if you have a 10-disk drive and you have 20 heads on that drive, drives didn't used to be this complex. They used to have this many surfaces. If one head dies, the rest of the drive might be fine for its lifetime, but that drive is discarded and destroyed. Today, we can now depopulate that head and then put that drive back into service through regeneration, and you have 95% of the capacity. So if you had a 20 terabyte drive, you now have an 18 terabyte drive. And that drive hopefully will have, in most cases, will have a normal lifespan from there on. And then disposal, and this is really what we're focused on today. Reuse, 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 recycling to a lesser degree, especially of the magnets. And then looking in the future, can we reuse some common parts like the magnet assemblies? So what are the barriers? And after this, I'll hand off to Jonmichael. But this is incredibly frustrating that the reason is security, security, security. You know, if you somehow, if you're a big CSP or you're an enterprise and you lose data, it escapes. People are extremely paranoid. This comes from end customers. This comes from the boardroom. This comes from senior executives in these companies. But if we get into really detailed discussions about proper methods for data sanitization, it works and it's secure. AES 256XT, symmetric encryption, is quantum compute resistant. And by resistant, that's a security word we use, but one researcher said today, if you took every computer on Earth, it would take a trillion years to break the encryption for a single drive. So that's what we mean by quantum resistant. It's that level. And then, data sanitization is secure and it's the most sustainable practice. We're going to be highlighting the most recent IEEE 2883 specification. That's the gold standard today. That's really the leader in data sanitization. Tens of millions of drives are destroyed each year. We have to fix that too, because I don't have a reference for 200 million, but that was my estimate of how many drives are. If you look at toll drives retiring every year, it's close to that number, and they're just shredded. They're taking a 30,000-mile Toyota Camry and just destroying it instead of reusing it. So what I'll hand off with is creating a sustainable data sphere really requires a new mindset. We have to, security is important, but so is the planet warming by 3 degrees. That is the kind of trade-off we have to see. We're starting to see momentum that way. Sometimes short-term, sometimes it's a longer-term game, but we're going to get there. Now I'll hand off to Jonmichael.
Thanks, Arie. So we mentioned, during the research for this white paper, I used to work at Intel, developing solid-state drives, and obviously I'm very familiar with encryption technology and the media sanitization features on drives. And we went and interviewed ITAD providers, that kind of released this open software that does this drive erasure, drive wiping, sanitization. In the sanitization world, that's like wiping and all that stuff is like bad words. We don't use those words. Media sanitization is a process that is well researched. We understand it. And there are specifications that dictate how they operate and work. And then, of course, we talked to hyperscalers. And the number one barrier we heard was security, security, security. And this was unfortunate, right? I mean, Morgan Stanley just got fined, I think, $35 million from the SEC because instead of actually properly sanitizing the drives, they just hired some mover guys to come pick up the drives and take them away. And it's like the nightmare scenario. You're like, oh my God, there's like my bank account's on some drive, and that quite literally happened. So these kind of events don't help the cause. I know it just makes people even more paranoid of like, oh, they don't know how to remove the data from the drive. But and obviously, these CSPs are building trust with their customers, especially like if you're hosting cloud service. You're putting data in there, and you're trusting that that cloud is not going to just leak your data or give it to another customer or let somebody else access it. Like these are pretty common things. It's frustrating that breaks down at the end of life. That when the drive's done being used, they suddenly say, okay, well, maybe the data was encrypted on the drive the entire life, but we properly sanitized it, but we're not sure. So we're just going to be extra sure, and unfortunately, these policymakers and people that are dictating the security and liability are not necessarily experts on media sanitization. So we're hoping that we can inform these companies. Security and engineering can actually prevail over legal and compliance, and quite frankly, misinformation. So if you just Google, how do I remove data from a drive today, and look at pictures of unfortunately, you'll see yeah, just drill a hole in it. Frustrating. So as Arie mentioned, nation-state attackers or somebody who has sophisticated equipment. I talked to the folks at Drive Savers. These are if you break your hard drive, you send them your drive, and they can remove the platter and put it into another machine to basically recover the data. And so all these X-ray micronoscopy. So there's all these in the NAND world, you can actually pop the NAND die off an SSD and put it in a tester and try to recover data. So these are sophisticated attacks. Obviously, a hammer or a drill, these are not okay. And unfortunately, this actually doesn't happen, but there's this perception that there's a lot of bad SEO. There's a lot of companies selling shredders or their proprietary software, and they tell you they can do it better. What if we told you that all the drives could actually do this, and it was built into the firmware of every SSD and hard drive, and they all came with sanitization, and it can be free and open source? They don't want to tell you that, and they want to sell you the software. And so, as Arie mentioned, it's so frustrating that we said the number 200 million. We came up with the number of hard drives units per year are actually going down because the drives are getting much bigger and they're shifting over to these high capacity, mass capacity drives. The consumer hard drive market's kind of dying, obviously, going to SSDs, but it's a couple 100 million units a year. 5 years ago, that was like 300 million units a year. So surveying all the hyperscalers we talked to, they said, yeah, we shred 95% of it. So I don't think that the 200 million number is far off. SSDs is huge market, 469 million units in 2022 is the estimated. And it's like 70 million M.2 in the consumer space per quarter. It's insane, mind-boggling number of units. So this is a big problem. You don't want to have, and one of the things Arie mentioned, there is lots of life cycle assessment data on hard drives. We know what the carbon impact per terabyte per year is. We know the distribution from the use phase and the manufacturing. The SSD world is a little bit more muddy. It's unfortunately, a lot of the vendors are not publishing life cycle assessments and posting it to their websites, but there are some studies. This one study, it's called like SSD's dirty secret, embedded carbon. And it's kind of people that wrote it were kind of junior. They tried to compare like a hard drive versus an SSD and like a laptop. And anybody who has a laptop knows you don't use hard drives anymore. And SSDs cost about 5 to 10x more than a hard drive. So it's not really, comparing them is the wrong metric. But the important thing to know about SSDs is the embedded carbon comes from the manufacturing of the NAND flash. Just like we heard about all today, the more of that manufacturing of the NAND flash that gets moved to renewable energy, that's good for the embedded carbon. But unfortunately, today, it's a hyper-competitive market. It's this year especially, we're in a slight oversupply, going into the second half of the year. And vendors, quite frankly, are just thinking about how to survive, not necessarily, how do we move all of our fabs to renewable energy? It's a commodity business. And so this study estimated that the carbon impact and embedded carbon of SSDs today could be as high as 0.16 kilograms of CO2e per gigabyte, which is absolutely massive. If you think of hundreds of exabytes of SSDs, I mentioned that hundreds of millions of units. Dell did a LCA on I think it's R740 XD server, and they said 50% of the carbon from using the server was from the manufacturing. 80% of that manufacturing carbon was from the NAND flash on the SSDs in just an entire server. So not necessarily just on an SSD itself, but now it's actually consuming a lot of carbon on the entire server. And one of the ways you can reduce the carbon impact is by using a device for 10 years. And the good thing about solid state drives, they don't have moving parts, and the reliability and failure mechanisms are well understood. Drives can last for a really long time. We've seen these, AWS has spot instances that are running the SSDs I developed 12 years ago, and they're still running. It's amazing. In the white paper, we kind of describe, okay, so now, we have life cycle assessments. We kind of understand, the carbon impact of a drive, and they scale with capacity. And so how do we quantify the impact of a circular business model? So we had some. We referenced a paper that has this comparative impact where you're looking at the greenhouse gas emissions of a compared product, which is like a replacement product. In this case, it could be a refurbished drive or reused drive versus a brand new drive, and say, okay, in this refurbished drive, you're actually not using the carbon from the manufacturing. The other way to look at it is if, for instance, say a hyperscaler were to buy an SSD, use it for 5 years, and then return it to the manufacturer, then they could make an argument for getting rebated on the carbon for their scope 3 for extending the use of that drive for another 5 years. So instead of taking the brunt of the greenhouse gas emissions up front, which is what the protocol suggests today, you could actually spread that over some time. And that is done in other segments that we. And then this other consequential approach is just basically saying, if you were to employ a new method like circular business models, like what would the impact be? And we can make those, having life cycle assessment data allows us to make these comparisons. There is a lot of studies on hard drives and there's one by IEEE that was funded by Seagate and some others. This study basically suggested that they looked at the carbon impact of reuse versus other recycling methods. And so one of the, Google and Seagate did a study where they were reusing magnet assemblies of the hard drive, which is, they basically could take the magnet assemblies and move them to a new drive. And these have rare earth materials, so it's incredibly important not to just shred them. But in this study, reuse was actually 275 times better than recycling the material. And so people say, yay, recycling's great, but we can shred them and recycle the material. Well, unfortunately, all that material gets turned into dust and small particles, and it's very hard and ineffective, I guess, inefficient to sort through. And you can't get any value recovery out of that material because it costs more money to sort through all the dust and figure out which is the rare earth materials versus aluminum versus glass than it is to actually just toss it. So we want to, and you'll see when we talk about the Design for Circularity guide, is that I think of reuse as the gold standard for circularity. That is the highest value recovery in a circular business model. So what's the fix for all this? We have a new standard called IEEE 2883. As Arie mentioned, it is the gold standard for media sanitization. Sanitization, as defined in the spec, is a process or method to render access to target data on a storage media infeasible for a given level of effort. And we mentioned, somebody wants us to say, yeah, there's a 0% chance you can recover the data. But we can say, is it 11 nines? Is it 12 nines? I'll go through some methods that we talk about of how this is actually done on SSDs. But the specification outlines these methods and techniques on SSDs, on hard drives, on removable media, optical. And this is replacing the NIST 888. That was the old standard from NIST. This was written by many of the same authors. I'm one of the authors of the spec. I have there's a section called Sanitization and Sustainability, which describes, hey, please don't shred these things. They take a tremendous amount of energy and resources to make. So, okay, we have a standard for sanitization. What does it actually talk about? They describe 3 methods for sanitizing storage. Clear is a method, basically if you want to prevent somebody from basically taking a drive, grabbing it from a data center, popping in another system, and just reading the LBAs. So that's easy. We have format, deallocate. A quick overwrite. This will prevent simple and invasive data recovery. So somebody that has low-level access to Linux or block device. But the one we're going to talk about is purge media sanitization. This is really exciting because it makes it infeasible state-of-the-art equipment to recover the data, and it can be done very quickly. So in the SSD world, we have a crypto erase where you're actually changing the media encryption key on the SSD, and this can be done very quickly and then renders all the data inaccessible. And this is AES 256, as we mentioned, was quantum safe. The other is actually just block erase, where you actually just literally fire off the erase blocks in the NAND and then physically remove all the data. This is how NAND works. It traps electrons in a floating gate transistor or a charger trap cell, and you can use a block erase to effectively remove all the data. Destruct, funny enough, shredding is actually not an approved method anymore because the particles are actually too big in shredding. In the white paper, we describe a little bit more about purge and why it's so important, but this is really what we're recommending for media sanitization. And if you take one thing away out of this presentation today, it's where purge media sanitization is going to be able to allow people to reuse drives, and it is safe and secure. It can be audited. We can read the data back. We can do verification. It is not like mysteries. We actually can understand if a sanitization was performed properly. In the specification, we have lots of documentation on how to do that and exactly what commands and NVMe to use. It's all free and open source. The folks here will be talking about the Design for Circularity guide in a bit, but again, reuse is really what we want to prioritize, but there's other things like extending the life, understanding platform resilience and firmware and hardware, and making sure that the drives can be running for a long time. And of course, the materials that are used are incredibly important. So this is our ideal circular economy for storage. Somebody uses a drive for 3 to 5 years. They can even use it longer if they can extend the use and repair it in the field, get firmware updates, get reliability updates. Then they can sanitize, verify the sanitize, make sure all the user data is gone, and give it to a second use. The customer can use it for 5 to 10 years after that. And then they can go, and typically they can do a sanitize again. If it is broken, they can send it back to the manufacturer. We like to be able to recover components and subcomponents from those, especially from like hard drives. before they get broken down into resources and shredded, and then going back into the production for a complete circular economy of storage. This is possible. And so the call to action is please read the white paper. Of course, that was like number one. We have an entire white paper on OCP about this topic. So, we have a new specification called IEEE 2883. If you guys need a copy, go to the IEEE site or email me. We'll get you a copy. It's very important that we embrace these open source functionality for. It's very into the ethos of OCP having all this free and available and open source and just built into the drives themselves. We need to educate customers about the myths of data sanitization and security. This is something that's well understood. It's not a mystery. We can solve this problem. And we want to invest in the OCP specs and features for circularity. There are lots of good, in the white paper we describe many of the features in the NVMe spec and hard drive spec that enable a circular economy. So with that, I think hopefully storage can be a leading example for circularity in the ICT industry.